All right, so we had left off with, what was it, practice problem number 3 on page 85. Yeah. So when we look at moles, what is the simplest way that we say a mole is? Just tell me.
A mole is the atomic mass of an element.
Yeah, it's it's a pure you could say it's a pure substance. It's the amount of a substance that equals its atomic weight, or atomic mass. That would be the looking at. We've only done we will start doing compounds here shortly. Do we need to do any more practice problems on the top on page 85?
No.
Yes. Can we just do one more?
Review.
Okay, so 1, 2, or 4?
Definitely 4.
Okay, what is the mass in grams of 0.375 moles of the element potassium? Because one of the things we could say is, what is the amount in grams of 0.375 moles of potassium nitrate? That's what we're getting at. You don't always just do elements, you can use compounds as well. But with this, we've got 0.375 moles of potassium. Okay, again, don't do that, or do only just that. Why?
Because of what?
Yeah, because otherwise, what may happen when you're working on things, and you might not account for everything within a compound. So moles of potassium, how do we get that to cancel out in our second step? This is step 1 in. Okay, so for every mole of potassium, you have how many grams of potassium?
39.1.
And again, this is where we call this a molar mass. Okay, we got moles and we've got a mass, molar mass. These cancel. So then when it says how many grams of potassium is that, these two numbers are next to each other. So what is it that we do? Okay, upon doing so, we should get approximately 14.7. Correct? Okay, and one of the things that I usually do is I just tack a 0 on there. Just by choice. It's not something that you're required to do, but I just say, I like having 2 decimal places.
Can we do one more? We did number 3.
Are you confused?
Do which one?
3 or 4?
We did 3 already.
2 to 4.
Okay. Is that something you want to work on together or do on your own?
Can we start off on our own?
Okay, so you can start off on your own. It says, what is the mass in grams of 16.3 moles of the element nickel? Do we have an answer for that? Okay. So one of the things now, should you look at other sources or say other authors of textbooks, you might see something similar to this, like we have 0.375. They may have a multiplication sign in there, and then other authors do it that way. To me, this just makes more sense. And I think it's a lot neater doing it this way because I don't know if that confuses you. You know you're multiplying, okay? Even if it's 1 over a number, you're still multiplying by that fraction then. But anyway, does it provide the answers to you to the practice problems, or is that something that you just got to work out yourself? Okay, because what the author says, okay, when you do this for every mole of nickel, you probably wrote in, was it 58.9?
58.7. It's 6.9.
I just put 58.
Okay.
Yeah,
Okay, I just always go out to 2 decimal places, and upon doing so, this is another one of those aspects you're probably going to have to sort out in college when it comes to what we call significant figures. Okay, and that is depending upon how you are informed on how to round these to a specific answer. Since this had 16.3, I put that 0 on there. And chances are they just do to the 10th spot when they're doing these types of problems. So therefore, you're always referring to how many significant figures there are. Now we would just have 3 significant figures because you're coming up with an answer of 956.64 or 65, somewhere in those regards. So what happens is what the author is showing you or telling you is that they have that for an answer, which is what?
So they round up?
Okay,
Yeah, so we can round up.
because, no, just let me finish. Because what is said when it comes to significant figures, you go by the least amount of significant figures in that problem, and here, these are 3 significant figures, and what it comes out to be, like we said, was 956.65, okay? But if we only want 3 significant figures, it would be that, 957. But for our purposes, we round up to the nearest hundredth, which again is 2 decimal places, and that's what we will do in this class. But should this be where in college you may have to do that on your own, you have to decipher using significant figures. The tools are there, and that's something you may have to sort out. Okay, questions on this? Yes?
So we can't round it up to 58.7.
58, well, okay, for argument's sake, it probably isn't going to change it that much. 16.3 times 58.7, and you get 956.81. So, yeah, that's close enough. But answers, 2 decimal places, like this here. Okay, questions over this? Front row. We're good, good, good. Middle and back row.
Yeah.
Okay. Go ahead and erase this. So, you're not always going to be starting with moles. Perhaps you start with that of a mass. Looking at the bottom of page 85, they are starting with practice problem 1, 2, or 3.
2.
Okay, so how many moles of calcium are in 5 grams of calcium? Notice in the top set of problems, this asking for the mass. You're starting with moles. Here, you're starting with a mass and you're finding moles. You're just going in the opposite direction. So you have 5 grams. How do we cancel grams in our next step? Okay, so for every mole of calcium, you have, 40 something? Okay, our grams cancel each other out, and you are just left with moles, and that's what it is you are looking for. Can we say we got 0.125?
Do cross.
Okay, so what you're doing, you're multiplying and then dividing by that.
So yeah.
0.125?
Yeah.
That would be correct.
And then how would you label that? It would just be mole.
Moles of calcium. Okay.
Right. So what was the answer?
So, yeah, what did you get?
Well, did you take 5 times 40.08?
No,
Divided?
because it's on the bottom. You divide.
Divided.
Okay.
Yeah, so.
Okay. I want to do number 2. And I'm curious. Yes.
So if we had a worksheet or something, do you want us to write it out like this? Like,
This here?
yeah.
Yes.
Good boy.
So, in practice problem number 2, how many moles of gold are in 3.60 times 10 to the negative 5th grams of gold? So, if we had to write that out to a whole number, what is that number written out as? Yep. Okay. Yeah, so you have 4 zeros in front of that 5. So we're going to do scientific notation though. 3.60 times 10 to the negative 5th, and this is moles of gold. Okay? Or we have grams of gold. We've got grams of gold. Okay? Okay. Just like we did up here. How do we change that to moles of gold?
You got to put grams of gold on the bottom.
And then
197. Oh, no, sorry. 197.
okay. Notice again, your grams are gone. You're just left with moles, and that's what you're looking for. So, the reason we're doing that is so we can practice how you punch in scientific notation, because on the next page, as you would guess, we're going to be using Avogadro's number. Okay, so does anyone have questions on how to punch in scientific notation, or you want to do that on your own?
How do you do it?
Okay, so we take 3.6, go ahead and punch in 3.6. If you put the 0 on there, fine. If not, that's fine. If you have a calculator like this, okay, hit your second function, second button, it's in the upper left-hand corner here. And then what that does is, for instance, where you see sine, cosine, and tangent, when you hit the second, look at those 3 buttons. It's changing the function of those to, rather than sine, it would be sine to the negative first. Cosine, cosine to the negative first. But here, you hit the second, and above your 7 key, notice it says x to the negative first. But once you hit that second, it changes it to exponent. Go ahead and hit that. You should have a capital E that shows up. Okay? Then you just punch in -5. I think that's what it was. Yep. Now you've got that number in scientific notation. But you're going to divide that by what?
196.97.
Okay? And of course, sometimes it's just way more convenient to do that in this fashion. But one of the things that's going to happen is you're probably going to see this. I'm going to put this a little bit above.
Holy Sigma.
Okay. Of course, this is moles of gold. A way more convenient way of writing that, yes?
You do the scientific notation. So
Would you put
you do 1.83 times 10 to the negative 7.
Okay. And where that comes from, we're going to the right 7 times. 1, 2, 3, 4, 5, 6, 7. There it is. But this is a number that's less than 1, so it has to be to the negative 7th, and that is moles of gold. Okay?
I kinda like this.
Whoa, 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 whoa.
Well, keep that thought.
Only gets farther from
How do
here.
I do it on my calculator? I'm different.
Oh, yes, that's right. Who else has a calculator different than, I think? Oh,
Just
okay.
one different.
All right. So, in this case, go ahead and,
Oh, yeah, you can. I'm sorry,
okay, so once you got that punched in, that big double E there, go ahead and hit that. Then that is your scientific notation, hit negative and then 5, okay? And then divide that by your atomic mass, which was 196.97. Yep, same thing. You are welcome. So we have some sample problems on page 86. We leave that up to you because now we're using conversions with Avogadro's number, okay? What is Avogadro's number? Times 10 to the what? 23rd. Yep. And it's 6.022. So anytime you are discussing atoms, molecules, anything to that nature, you are using Avogadro's number at some point. Okay? And for every mole of a pure substance, okay, or a compound, you have 6.022 times 10 to the 23rd atoms of that pure substance, because it equals its atomic mass. So that's what they're referring to when they're using silver in sample problem D. All right, practice problem 1, 2, or 3 on page 86. Okay, so how many moles of lead are in 1.50 times 10 to the 12th atoms of lead?
Let me think.
Okay.
Avogadro's.
Let me be clear.
You're going to be using Avogadro's number. So remember, it's a counting unit, and for every mole of a substance, that's how many atoms you have in Avogadro's number. So when you hear it explained to you that way, it probably doesn't mean anything until you apply it. Okay? So we've got 1.50 times 10 to the 12th.
Think you dropped some.
Atoms of lead. So we probably want to know how many grams there are. Nope, how many moles there are. Okay. Okay. So, if we're going to cancel out atoms, where would that go? On the top or the bottom?
The bottom.
It'll go on the bottom, so we can cancel that out. So we have atoms of lead. Okay? So for a mole of lead, how many atoms would you believe there is?
206.02.
Nope, that would be a molar mass.
Well, we have to figure it out.
We have to find the moles.
Isn't it whatever that is times the molar mass or the
No.
molar
Holy sigma.
mass?
Nope.
Is it avocado?
Avocado's number.
Is it the
Okay.
atomic number?
23.
Avocado.
10 to the 23rd.
6.022.
Did you beat that?
Okay, that is a constant, just like 3.14 is a constant, 9.8 is a constant.
How'd you find that?
So Avogadro's number to find the atom.
Talked about that yesterday.
Shucks.
We recorded this yesterday.
No, I watched it. It's just that it was very little.
Okay. So now we've got everything to cancel. We're in moles of lead. So again, let's just follow along. We are doing 1.50 second, okay, above the 7 key where it says x to the minus 1, or you're hitting just capital EE, and we've got 12. Then we divide that by 6.022. Second, above the 7 key, 23rd, and you should get times 10 to the negative 12th.
That's pretty crazy.
Because when you're dividing, you must what? Subtract exponents? Is that what you do in algebra 2?
Yeah.
If you remember that. But so the division here,
Oh, the sigma.
I was thinking it should be times 11, but no, it's 12. Did you get 2.49?
Yeah.
Okay,
2.49 times 10 to
Yeah, we know.
times 10 to the negative 12th. Okay,
Actually, negative 12.
Someone's lost.
Mine's is 36.
did you divide or did you multiply?
I divided. 'Cause I still got 2.49.
I'm thinking, did you use the exponent key or did you use that caret, that funny looking thing that does this?
I used this one. The second.
Well, you got to hit second and then that. Okay, well,
I probably screwed up something.
try it. Well, that's what I'm saying. I'm saying try it again.
Try it again. Okay. Okay, 1.50 times 10. And then I do the second and do that one.
No, it sounds like you're hitting too many buttons.
That's what I did. And then second that one.
See, you're hitting too many buttons.
How am I hitting two
Just
numbers?
clear
Oh,
all that out. Okay, so start it out again. Hit second.
Without putting the times there?
Nope, because
Second.
see, you're multiplying the whole thing times 10.
Okay.
That's a different function, what this is. Did you hit second?
Yeah.
And above the 7 key, that one.
Mhm.
Okay, now that's saying you got an exponent there.
Yep.
So go ahead and hit 12.
Okay.
Then divide that
Okay.
by Avogadro now.
Ah. Two.
Second.
Second. That.
That.
23.
Blue.
Yep.
Okay. That makes a little sense.
Someone's lost.
All right.
That's in there, man.
Okay. Do we need to do any more practice problems on page 86?
No, thank you.
Probably.
Okay.
Sorry.
So we've done two-step problems. As you're guessing, there are three-step problems.
I love English.
Okay? So on page 87, what happens when you have a mass of a substance and you want to know how many atoms there is? Or if you have how many atoms there is, what's the mass of that? That's what this would refer to. So on page 87, problem 1
Yes.
or 2, okay? 1. So what is the mass in grams of 7.5 times 10 to the 15th atoms of nickel? Okay? Do you want to try that yourself or do we work on it together?
Probably together, since they
Do we do it together and then do one on our own?
Sure. Okay. So for step 1, we have 7.5 times 10 to the 15th. Okay. And then our substance, it was, wasn't it?
Yeah.
Okay. And that was
10 to the 15 times.
so this is atoms. Okay, so there's step 1. Remember the prior problems we were doing were 2 steps. I just got to go a little further because I probably write a little bigger than everybody else. Okay, so how do we cancel atoms in our second step? You put it on the bottom with Avogadro's number. Okay. So for every Avogadro's number in atoms, we get exactly one what? 1 mole. Here's our counting unit. Okay. And this is where we would have stopped in previous problems. Our atoms are gone. We're now in moles of nickel, but we want mass or grams of nickel. So our final step would be what?
Divide by. Oh my. Would you do the same thing we did in the last problem?
Divide by 558.6.
You take 7.50
No.
times
Wait, what was
10
it again?
times,
Sorry.
you times them, multiply.
We want to know how many grams of nickel are in here.
Multiply.
So do we divide or do we multiply?
Multiply.
You multiply.
Grams to the moles.
Right. Because for every mole of nickel, you have 58.69 grams of nickel. Those are gone now. Okay? So there is your 3-step problem, and we should get 7.3 times 10 to the negative 7th. Correct?
Let us solve.
Well, these two numbers are next to each other,
So you multiply. Then
so you
divide by
multiply, then divide by that.
that. Holy sick.
Okay. Yes.
Wait, what'd you get? Wait, hold on, wait.
7.3 times 10 to the negative 7th.
Sir,
Okay?
Divided by avocado's number.
And that'd be,
Then it equals.
holy moly.
Okay.
Holy guacamole. Avocado.
So you can do practice problem number 2 on your own. It says how many atoms of sulfur are in 4 grams of sulfur. So rather than going in this direction where you're starting with atoms and finding grams, you have grams, and now you're going backwards to find atoms.
What did you say what the answer was for
7 point something times 10 to the negative 7th.
7.31? Okay.
That's correct.
will be like across.
Okay, so then this was practice problem number 2 on page 87. I think I had hit pause for quite a while. It didn't record at that time, so I'm just going to quickly go through that. 4 times 6.022 second exponent, that's above your 7 key, 6.022 times 10 to the 20th. I think I just did that twice. Darn it. 4 times 6.022 second exponent 23rd. That gives you 2.41 times 10 to the 24th, but we need to divide by 32.06. And we get 7.51 times 10 to the 22nd. So like I said, what you students were discussing amongst yourselves, you can do this up to this point and stop. Then you've got it in moles of sulfur. Then another step after that, your moles of sulfur times 6.022, and you get the same answer. But when you break it up into pieces, you might be off by a 1/10 or a 100th, which is not that big of an issue. Okay, that's all I have for today. Next week we will, I just haven't wrote it in yet, we will sign our first papers and move forward from there. Then we'll start throwing in compounds instead of just elements, where it might be if you have 15 grams of ammonium nitrate, how many atoms of ammonium nitrate do you have? Rather than just doing singular elements, we'll start throwing compounds into it. We will catch up to you next time.